All righty. I didn't even make it all the way through the comments. Welcome, everybody. I'll hit these last few here. All right. Welcome, everybody. Hope everybody's doing well. As you can see, I am out in my shop. First time I've been back out here in, I don't know,
Months.
probably 2 or 3 months, I guess, or maybe longer. I don't remember when the last one I did from out here, but wanted to do one out here. Had to pull the golf cart out. It's sitting just on the other side of that garage door there, and had to move some stuff around. But I think I got it set up right. We'll see. We'll see how it goes. You know me and cameras sometimes. Sometimes they're a little challenging for me. But anywho, Mr. Paul, what do you know good? Anything?
Yeah, my buddy Matt Haas asked me to 3D print something for him. So I'm in the process of taking the supports off of it, and boy, they're a nightmare to take off. This was
Uh,
a 36-hour print.
Holy cow! That looks like it'd be easy to
Yeah,
break too.
yeah. It's yeah. It, but I don't want to do that and then break
That
it.
would have been awesome if it would have just snapped in half right then.
But I'm not real happy with the way it came out. So, it, uh, but yeah, it's quite a thing. So anyway,
36
that's what I've
hours.
been working. Yeah, 36 hours.
I don't think probably about 12 or 14 hours is the longest I've ever done anything. I can't imagine 36
Yeah,
hours.
it's quite a thing.
That is a long time.
That's
All righty.
yeah. When it, that's what's been keeping me busy.
All right. Well, that's good. At least you're doing something, buddy. At least you're doing something.
At least I'm doing something.
I don't know how well this light is. All right, Mr. Ryan, what's up with you?
Same old, same old. Just trying to get ready for this show this weekend. To printing out a bunch of stuff and getting irritated and printing out more stuff and then getting irritated again. So, you know, it is what it is.
All right.
Yeah.
I'm gonna try to turn my volume up a little. See if I can hear y'all better. Well, um, I thought, as y'all know, there's something new going on around here, and I thought I would talk about that tonight. I've been getting some emails with a lot of questions about various things, so I thought I would just kind of go over some of it. I've got my build right here behind me, and it is still not complete. There's a lot of things I tell you, I've been griping about Amazon here lately. I don't know what their deal is, but here lately, if you order something on Monday and it says you're going to get it Wednesday, 2 day shipping, and then the next day, Tuesday, you order something else and it says 2 day shipping, so it'll be Thursday for that item. Well, you can bet you're not going to get that thing on Wednesday that they said you were going to get, because I think they're looking and going, oh, we'll just wait and go Thursday, make it all in one trip or something, because it seems like the more stuff you order, you're going to get it on whatever the last shipping date is. So I got some couplers that were supposed to be here. They were supposed to be here yesterday. And they said, "Oh, we're sorry, they're delayed. They'll be here today." And I've also got some black filament, Tech Bears filament. They were supposed to come today, and I kept thinking, "I wonder when they're going to show up." So I asked, who EXA lady. And she said, "Oh no, they'll be here tomorrow. They always do it once." So I don't know what it is with those couplings, but it's the second batch I've ordered. The first batch I didn't read the fine print, and they weren't. They were the right bore size I needed, but they weren't the right physical size. They were real dinky, and of course it took about 5 or 6 days to get them. And then when they showed up, I'm like, oh well, now I got to get them again. But now it's going to take another 5 or 6 days. I did get 2 of them yesterday, so I have the ones that I want to use are on the back on the y-axis, but I've got these kind, and I hate using these kind. That's still on the Z and the x-axis, so I'll be swapping those out as soon as those other ones get here, if they ever do. So
Nice.
I thought somebody was going to say something there. All right. Well, if anybody's got any questions they want to ask, be sure and put them in the chat. Paul and Ryan, I'm sure, will keep an eye out for me on those. But I was going to talk about a few different things. And by the way, the response to the new plans has been fantastic. And also, I created I figured, heck, I might as well do another Facebook group just for the Gatton CNC 2.0. So I created that yesterday, and I think we've already got like 40 something members.
Nice.
That have requested to get in on that. So, and I didn't send out any of those annoying invitation things that everybody does. I hate getting them, so I thought, well, I'm not sending them out. People will see it, and if they want to get in on it, they just go ahead and ask about it. But anyway, let me. Oh, I had to scroll down. Let me see if there's any questions.
I just put one on the screen, David.
Okay, NEMA 23 closed loop steppers, Dave. No, they're not currently. I don't know for sure what I'm going to end up doing. It will be either NEMA 23 closed loop, or I might even go with NEMA 34s and just machine myself some adapters, which would be a good first project for this thing, I think, out of aluminum. What are you chewing on? I got to do a dog check because I got electrical wires running. Yeah, that's what I figured. You little shit. I'll let you chew one in two. It'll light you up, buddy. What is that off of?
Yeah. Yeah.
Oh, I think he got this off of this is some 3D print off of something. But yeah, I've caught him a couple of times chewing on I have one of those extension cords on a reel right up here where you pull it down. Well, you know how it has that little ball to keep it from you move that ball. Well, I've got it all pulled down because I've got an extension cord on. Well, he gets to chewing around on that, and I keep saying, man, you're gonna catch the wrong thing when I'm not watching, and it will light you up if it don't kill you.
Gonna have to rename him Sparky.
Yeah. But anyway, back to the stepper motor thing. One thing you have to remember as I talk about this build that I'm doing right now, you got to remember that this is not my first rodeo. This old guy has built many different CNC machines, and when you do that, you accumulate a lot of parts. So a lot of the things that I'm using, at least temporarily right now is because I already had them. I've got, I don't know how many different NEMA 23 stepper motors. I probably got 15 or 20 of them. But what I have on there right now is some, they're actually the old Xylotex steppers. They're the 425 ounce, 3 Newton meter, I think it is, uh, 4 amp. So that's what that's again, it's just because I had them handy. And I thought, well, I can stick that on there and get it to moving around and then decide what all I want to do. But I think I'm kind of leaning towards the NEMA 34s because that's what I have on this other machine that I have, the big one. And man, that thing, they'll go through anything with those on there. So, and of course, my Avid that I used to have had NEMA 34s on it as well. So, yeah, the stepper motors are the open loop for right now. Another thing, I guess I could turn this on. I turned it off because it started getting warm inside this little console that I threw together. And I made the back today and screwed it on. And then I realized a while ago that I forgot to put vent holes because I need to get a little computer fan and pull that. But let's see. Yeah, you can kind of see me.
Yeah.
But I made this where this just lifts off. I just 3D printed some stuff and glued it on there. But the two power supplies are right here, so they do put off a fair amount of heat. But I'll have to put some vent holes, take that back off, and all this stuff I just have screwed on the top and the back today because I've been still wiring up homing switches and all that kind of stuff. So but I don't know how well you can tell. Let me see if I can. We'll just do this. I don't know if that looks familiar to anybody, but that's the Masso 2nd generation controller. It's mounted just on the other side of where this monitor is, but I just kind of threw together this little console. This is a touchscreen, but like the same one I used when I was building that other machine, it's not compatible with the Masso, so it works as a screen, but it does not work with a touchscreen. So that part don't work. So that's why I have this here, which is what do you call these things, Bluetooth or whatever. And I guess I've hit the. Oh, I don't like that. I thought. Nope, it must not be the. Okay. There's two different password things that come on, and the first one I have where all you got to do is hit enter. In fact, so there's no password. It just pops up and you just hit enter. And then the second one, when you go in setup, I still have it where you have to type in the password, and I wasn't sure which one was up there. I was thinking it was the other one, but it was the one where you just hit it. But anyway, yeah, so I'm using this this old Masso. So all this is old stuff. The stepper motors are old stuff. Even the you can see right here the little what do you call it, proximity switch or whatever you want to call those.
Yeah.
Those
Limit
are
switch.
all. What's that?
The limit switch.
Yeah, I got one like this on the Z and another one back there on the Y-axis. And then for the x-axis, I have one of the cylinder type, uh, and then I have a little metal aluminum angle piece where it reads it when it goes over. And I can take the camera and go around back and show you different things back there. But anyway, let me just talk about a few things that I wanted to talk about, because I know we've got some folks that have already bought the plans and are trying to plan their build and stuff. But one thing I wanted to talk about is, you see this piece of this is that 2020 aluminum extrusion. There's another piece back there. They're just sitting here. They're kind of snug because I took these out to the chop saw and cut them at the same time so I'd get them exactly the same length. And I cut them to the length of 29.921, as close as you can get to that with a chop saw. But that's to use to help keep these things parallel, because we all know how important it is when you're building a CNC machine, is that you got to keep everything parallel, and you also got to keep it square. So those are kind of used to pull, fasten down one side and then pull in the other side to make sure that it is exactly parallel going this way. And then for those who have bought the plans, I have added to the website on there the different dimensions, because since I've got the complete CAD models of the whole assembly, I went in and took a measurement from this edge of the front plate and that same edge back there caddy corner on the rear plate, which is what you would do when you're trying to check squareness. So what I did is I posted on the website, because when people start building these and they start pulling a tape, I've given them what number they need to look for to know that it's square. For this particular one, which is the smaller of the four machines, the number going across here, and again, you're reading it with a tape measure, so it's how good your eye is calibrated, I guess. But the number you're looking for is 54 5/8 from caddy corner to there and then caddy corner to there. So you want to get it as square as possible, as well as keep these things parallel with these little spacer things. And you don't have to use, I just happen to have something that was long enough that I could cut this aluminum stuff, but you could just use a piece of wood or whatever. It doesn't matter. Just cut two pieces. Make sure you cut them exactly the same length, and then that way you can stick them in there. And like I said, I can with a little force, I can pull this one out, because it's I scratch at my paint job doing it, but those are just there to keep the thing parallel. Some other things I want, and again, I've got all the dimensions for the different sizes to, the squareness numbers are all on the website for the different sizes, because I figure, well, since I have the CAD models, I might as well measure them in CAD. And, of course, that's a perfect world, but, that's the number you're going to shoot for, and try to get as close to it as possible. But I've got it for all four different sizes. Let's talk about the different sizes for a minute. When I got ready to start drawing this thing up, modeling it up, now it's been probably 2 or 3 months ago, how long I've been working on this. I wanted to create plans that were kind of like, the old Garage Works. Of course, it's a plywood machine, but I wanted to try to make it where the average Joe could make one of these things without doing a whole lot of really hard work, and to make it where it's as easy as possible, that I'm supplying all the information about every screw, not just this screw is a button head, but it's an M8 by 40 millimeter long. So, you don't have to guess at what hardware to get. It's all spelled out. the size, the pitch of the thread, as well as the length that you need. But what I did is when I started looking online to make sure what was readily available with these different things, well, when you go to get this extrusion, you can pretty much get it whatever you want. But the 80/20 website, which is where I got all this stuff, these two pieces and this, right off the bat, they have a thing where one of the selections is 900, 1200, and 1500 millimeters. So I thought, well, that's pretty much common sizes for ball screws and linear rails. So everything you see is all based around what's readily available from Amazon or from the 80/20 place or wherever, wherever you want to get it. So both of these rails, and this is 40 series, what they call 40/80, is 40 millimeters wide by 80 millimeters tall. They are both 900 millimeters long. So I ordered those two. And then this heavier one here is the 40 series 80/16, which is real popular among CNC builders and even companies. Most of them use that for the X-axis. But that is also 900 millimeters long. And then as you look, these things are hardened, so you don't want to have to try to cut these. These are all 900 millimeters long. So I bought, these things actually come in a set of two. So you get two rails, two linear bearings on each rail. So you get 4 linear bearings. So I bought 2 sets of those, which gave me 8 linear bearings. So I've got 1 linear bearing here and 1 linear rail here, one on the other side, the right side, and then of course the other 2 on the X. So and those things, all this kind of stuff has really come down in price from what it used to be back in the old days, because that's why I never built them out of this kind of stuff, is it was real expensive back then. So all this stuff, none of this extrusion is cut. You can cut it with a regular chop saw if you've got a carbide tip blade in it, which most people have that in their saws probably nowadays, but you can cut it. But the way these 4 different size machines are designed, you don't have to cut any of the extrusions or the rails or the ball screws or any of that stuff. It's all order it. When it comes in, you open it up and you bolt it on. Again, 4 different sizes. This is the smallest of the 4. It's going to have, I'm calling this a 2x2. If you really wanted to work it out, you could probably have a cutting area of about 26 by 26. I'm setting it up where I'm only worried about getting 24 by 24. So that's going to be plenty big enough for this one. The other, somebody got a question? Okay, I thought I heard something.
No, I don't think so.
Okay. The nice thing about these 3 designs is you got a 2x2, a 3x2, and a 4x2. So all 3 of those are going to use this same size. The left, I'm calling this the left Y-axis assembly. That's going to be the same. The right Y-axis assembly is going to be the same. So those are going to be the same for either the 2x2, the 3x2, or the 4x2. The only time it gets bigger is when you use if you go all out and want to do the 4x4, and then these 2 will be 1500 millimeters, and this will be 1500 millimeters, as well as the ball screws and the linear rail. Everything will be 1500 millimeters on that one. For the 3x2, like I said, these are going to be the same. So you'd have 900 millimeters here and 900 millimeters here. Then this piece right here would now be 1,200 millimeters. This would be 1,200 millimeters long, and then these would be 1,200 millimeters long. And again, all this stuff is readily available right on Amazon or pretty much anywhere, any place that sells linear rails and ball screws. Uh, that's a real common size, 900, 1,200, and 1,500. So the 3x2, that would be 1,200. Now when you go to a 4x2, again, these would still be 900 millimeters. This, this, and this would then all be 1,500 millimeters. So the design is pretty much the same. The only thing that changes is ordering different length parts depending on what size machine you want to build. The front plates are going to be all the same. The side uprights here are going to be all the same. The rear plates are all the same. Uh, all that's going to be exactly the same. There's no difference. It's, you know, if anybody knows me very well, they know that I believe in the KISS theory of engineering, which is keep it simple, stupid. Too many times engineers like to engineer too much, and they engineer cost and complicity into something that doesn't need to be like that. So try to keep everything simple. That's why even though there's 4 different sizes, the videos that I'm doing by showing how to, you know, I've got the first video, I put this left axis assembly together. The second video, I put the right axis assembly together. The third one, I think I did, or no, I think the first one I was showing how to different ways to make the plates, which we'll talk about here in a minute too. But anyway, all the different things that I'm doing for this one, as far as watching the videos, it's going to be the same thing you're going to do for any of them. The only difference is which size you're building. You're like, if you're making the 3x2, then when you watch the video where I put this together, the only difference is yours is going to be 1,200 millimeters long instead of 900 like mine. But other than that, it's all the same. So let's talk about the different plates a little bit, the aluminum plates. Probably.
I got a question here, Dave.
Okay.
I put it on the screen.
How much bit coverage do you get there? 900 millimeters is 35 inches in a gantry, each part of it. Yeah, I know that you can get, if you really work at it and set, depending on where you set your limit switches, if you max everything out where it goes to where it's just a hair before it's touching and all that, you can get about 26 by 26 inches cutting area out of this. I'm having mine set up where it's going to have 24 by 24, which is why I'm calling it a 2x2. All these machines, when you do the math and figure out what you're going to lose and all that, the one that I'm calling a 3x2, it's really a little bigger than 3x2, but I'm calling it that because that's a safe bet that you're going to get at least that much. Same with the 4x2, same with the 4x4. You'll get, you know, with a 4x2, you'll get easily 24 plus in the Y and 48 plus or 36 plus in the X. Because like I said, all these are pretty standard sizes, 900, 1,200, and 1,500 millimeter on this stuff. So, all right, now, as far as the plates are concerned, I have 2 different thicknesses. The front plates and the rear plates are these small pieces. They are 3/8 6061 aluminum. If you wanted, you could make them out a 1/2 inch because the other stuff is 1/2 inch. And if you wanted to not have to buy 2 different thicknesses, it wouldn't hurt anything. making this an 1/8 of an inch thicker instead of 3/8 being a 1/2 inch, because it's sticking out this way and out the back. Might change your spacers a little bit if you're putting spacers on your stepper motors or whatever. Um, but if you wanted to do that, you could. I had a chunk of 3/8 sitting around the shop, so that's what I used, and that's plenty sturdy enough for what that's holding there. The uprights are 1/2 inch. There's this right here that the Z-axis assembly is bolted to. I call that the XZ mounting plate. It is 1/2 inch, and then there's also 2 spacer blocks that kind of pull it out enough to get the ball screw nut housing behind there. Those are all 1/2 inch. Um, One part you don't see on here that I haven't made yet. It's going to be probably one of the first things I cut with this machine when I get it uh, all wired up with the spindle and all. As you see these tapped holes on either side of here, that's where the tramming blocks go. I've got the same tramming blocks on my big machine. It worked out really well, so I just made everything exactly with the Z-axis like what I had on that other machine. The Z-axis assembly is one this is a purchase part off of Amazon. It's sold by a company called Rat Motor. You probably heard of them. You've seen them on. I had bought this exact same one on my other machine. That's why I felt confident, because I've been running that for about a year now, and it is a good quality. Uh, it's really good quality, and it has the same 20 millimeter linear rails and 16 millimeter ball screw. It doesn't have the skinny 12 and that like some of them do. So it's good and beefy. And I don't know how China does it, but they get those little 12-year-old girls over there making these things or something. I don't know how they do it, but the price actually went down. When I bought that one for that machine a year ago, it was $186, I think. This one was $170. And another thing about these is when you go to purchase this, you can see I've got the travel is just under 8 inches. They call it 200 millimeters, which is 7.87 or something. I forget. A little under 8 inches worth of travel. But they also have them anywhere. This is 200. They have one that's 100, 300, 400, 500, and 600. So depending on if you needed a lot of Z travel, you could customize that part of it just by which one you order. But all of them are going to be the same. They're just going to be either taller or shorter. The one that's got 100 millimeters worth of travel is going to be about half this size. But they'll all still mount the same and all that. So, and they're all the other same components. But I didn't think it was worth trying to reinvent the wheel, because there's no way I could. And this thing actually, if you start putting the calipers on there and measuring the thicknesses, this and this I think is the same thickness, but the back plate is a little thinner. There's some kind of like tubing or something, and you've got the rails, the ball screw, the linear bearings. I don't see how in the world I could buy the material and make this thing for what they sell it for, especially when I include my time, because there's a lot
going on that thing.
Yeah, and they're over there in some little factory making hundreds of them a day. So, but to try to do all that, I just thought, no, I'm going to go ahead and do just now. When I got this one, I took it into my office and took it all apart. So I reversed, because I didn't have a 3D model of it, but so I took everything apart and dimensioned it and created the 3D model. So that's why I have a 3D model that you see in those pictures. But this is a purchase item, and like I said, if somebody wants to try to build one of their own, more power to you. But you're never going to be able to do it for what they sell these as. Uh, but
Jeff Connor just said he just bought your plans.
Okay, good deal, good deal. Um, let's see. Well, let's get back to talking about the plates for a minute, because I know that's going to be probably one of the most challenging things for somebody to make. And I have thought about. I mean, let's be honest, folks. You've heard me say this a million times. Building these CNC machines, it is not rocket science. Uh, the companies that make them and sell them might want you to think it is, but that's what the whole purpose of these plans are, to show you that you can get the same kind of components, and with a little sweat equity, as I like to call it, you can build a machine that's just as good, if not better, than what you could buy. And it's going to be a whole lot less money because you're putting in the work to build it yourself. But I know the plates might be a challenge. If some of y'all might have seen some of the little video clips that I shot where I was cutting all this, God bless Cody Elkins, because he had those awesome O-flute bits that just chewed right through that stuff, 1/2 inch, 3/8, whatever. So I cut all of these things right over here on this other machine that's got the same spindle as this, same Z-axis, same pretty much everything. It's just a little bigger machine. So, I'm fortunate that I have a machine that can handle cutting that aluminum and making really good parts. Now, I realize that a lot of people that want to buy the plans and build a machine from those plans may not have that. So I've tried to come up with some other creative ways for them to lay out the holes. Naturally, they're going to get PDF files of the drawings for each one of these parts, which will have dimensions telling them where all the holes go and what size hole and if it gets tapped and all that stuff. But I can tell you, I definitely would recommend that only use that method as a last ditch effort. If that's the only way you've got to do it, by looking at the print and scribing lines and all that, because that's probably going to be the least accurate way to do it. Let me grab some stuff over here. What I have done is that's also included with the plans, is some STL files for 3D prints. Pretty much everybody's got a 3D printer. So I've made STL files. I'm gonna have to take a quick break and go check on Knucklehead real quick. Let me.
So we can 3D print a Gatton CNC 2.0.
Yeah, let me drop that off for a second. I'll be right back.
He's got to look for Sparky. Let's see here. What's it? Leo's asking if he's only selling the plans only. Yeah, he's only doing plans. So you purchase the plans, and it comes in every file set imaginable, and then you're off to your own devices on it. Let's see here. Hendrix is looking at 36 inches deep, but 32 would work. Well, I mean, you can build a deeper machine then. I mean, the plans that he's got there are pretty flexible for it. So, so you could probably get you can get 1,000 millimeter, rails and stuff like that. So I don't think that would be a big deal. Let's see here. Can the parts be cut out on my CNC plasma? You probably, well, you could.
Okay,
I'll let Dave answer that, but I believe you could do the outlines with the plasma, and then just manually do the holes for the screws and all that.
okay, let me
look at it. Hey, Dave, I've got a question for you.
okay.
Jeff is asking if whoops, hit the wrong button there. There you go. Can he cut the parts out on a CNC plasma?
Yes.
And I was thinking that he could do the outsides of it, but he probably would have to do the holes manually or some other method because I've never cut with the plasma, but I know that they're not like you're melting the metal, so the holes for the mounts might not be,
especially because so many of the holes require tapping, and when you cut stuff with a laser or a plasma, sometimes that'll harden the stuff, so you break a lot of taps trying to tap it. You almost have to take a drill bit, cut the whole undersize, and then come back with the drill bit to clean the hole out and then tap it. So that may be more trouble than it's worth. But let me just go back to these, talking about the 3D prints real quick here. I've got files, STL files for all of the parts that you have to fabricate from aluminum. And if you notice, well, I don't know how good you can see, all of these holes are for a 1/8 inch, where you would take a 1/8 inch center punch. Oop, I grabbed the wrong one. No, that might be the right one. It's a little snug. But anyway, so you would lay this on your aluminum plate and move this center punch around and tap, and you put the little tick mark to lay out all the holes. And then when you take them to a drill press, and hopefully you got a drill press, and don't try to hand drill them because it's really hard to keep holes straight with a hand drill. But you put them on a drill press, then you won't have the drill bit walking around, and you can look at the drawing to see what size hole goes there, and then drill them out and do it that way. So that's why there's the 3D prints. Now for the ones that are the uprights, you can see what I've done is because not everybody has a 3D printer that's big enough to do this in one piece, which I don't. So I made this where for the right and the left uprights, there are two different pieces. And once you put them together, they are hard to get apart. But anyway, that's how they go together. And I've also made it where you can't mix them up. The male piece is opposite on the other side. So, these would be good to lay these out. You'd be surprised how accurate you'll get with this. Now, if you don't have a 3D printer to utilize the STL files to make drill templates, but you do have a laser of some kind, like a diode laser or CO2 laser, whatever, you could make these take the STL files and use them to create this same kind of drill template out of 1/4 inch plywood or 1/8 inch plywood or whatever. Same thing. So that would be another way to lay out the holes. Another way is, let's say you have a CNC, but you just don't feel like it's strong enough to handle the aluminum. What you could still do is buy your aluminum flat bar, clamp it down, and put you a little center drill or even a drill bit of some kind, something small, like 1/8 or smaller probably, and then use the one of the other included files, which I've thrown all kinds of files at folks, so there ought to be something in there that you can use. I have step files, I have DXF files. I have SVG files. I have the STL files. I think there might be one more I'm forgetting. But I'm trying to throw all of that in there, knowing that people are going to pick the best method for them with whatever they happen to have. Uh, I mean, if you don't have anything, but you know somebody else that's got a CNC that can handle aluminum, then they could either use the DXF files or the SVG files or whatever to run in whatever they're using, Fusion 360 or VCarve Pro or Carveco or whatever. There'll be some way to get the file to be able to cut these parts. But like I said, if you've got a CNC but you don't feel like it's strong enough to handle the aluminum, you could just put that little center drill and just have it come real slow. It might take a while, but just have it come real slow and mark the holes. Again, putting that little tick mark so that then you could take it to the drill press and you'll still have the accuracy of a CNC as far as laying out the holes. That's the main thing. Now, another thing I want to point out, as Ryan was quick to point out in the Facebook group, there are some radii and some different shapes to this.
I know you did that just for me.
They are. I know. See, that's so smooth right there. That little radius on there.
Look at that.
All of these, if you do not have a way to cut this, but you do have a way to lay out the holes, rectangle flat bar will work fine. I should point the camera over at my other big machine. Ryan gives me grief about it all the time because those uprights, I never did cut any kind of shape to them. It's just 1/2 inch by 8 inch wide rectangle flat bar. That's all it is. But that machine don't know any different. It runs the hell out of everything I put in front of it, whether it's got fancy ones like this or just rectangle ones. So if you don't have a way to do that, you can still use the templates, just butt them up to the corner and just leave that rectangle like that. Same way with these things, you could just make, that you plate where it's a rectangle like coming out here. That notch not being on there, it looks nicer with it, I think, but it doesn't have to be there. It would still work. The main thing is to get these holes in the right place. Let's see what else.
I call those corners on the other one OSHA corners.
Yeah. Well, like I said, that old machine, it don't know that those corners are sharp, and it runs like a
yeah. Well, it's going to get jealous of the new Gatton CNC 2.0.
But yeah. Well, it's going to get all the dusty jobs, the wood jobs. This is probably going to be my aluminum cutting machine over here. So not that many parts to cut as far, you got 2 in the front, 2 in the back, 2 on the sides, and then probably the most complicated is this XZ mounting plate. And that's only because, as you see, the Z-axis mounts to it. It's got some counterbore holes. So if you got a CNC machine to cut that, it's no problem. That machine over here behind me cut it no problem, especially with those wonderful bits from Cody. But I almost hate to say this. I'm not going to get in the business of making aluminum plates to sell, but if anybody buys a kit and they are working on it and they just cannot figure out how to make some of these parts, especially this one that's got the counterboard holes, contact me and I'd be happy to work with you. We'll work out something. You can buy some aluminum and have it drop shipped to me, and I can make that part for you and send it to you. I don't want anything to be a stumbling block for somebody to start putting this thing together and go, crap, I don't know how to do that. So, that's not the whole purpose of this. This whole thing is made to be where anybody, and I mean anybody, with a lick of sense can put these machines together, because Heck, I've been doing it for years, and you see how stupid I am sometimes. So, all right, I see we got a question on there. How much wiggle room do the HBR holes around your screws? Adjustability. What do you mean by HBR? I'm not sure I know what you're talking about. If you're talking about the counterbore holes, like this plate right here, where this Z-axis assembly, the one that I have, the 200 millimeter, it has, and I point this out in the video, it has 5 sets of 2, so it's got 2, 4, 6, 8, 10 different holes. Are 60 millimeters apart this way by 60 millimeters apart that way. So when I did this plate, I did 5 sets of 2 holes, but I've got them 60 millimeters apart this way, but 30 millimeters apart that way. And
He's
they're
talking
just
about in the rails.
what's that?
He says in the rails.
Are you talking about here? I'm still not sure what. Anything that's a through hole, I mean, it's not super sloppy, but there's room. You know, one of my favorite old sayings is, if you can't be precise, you better be adjustable. And I mean, where the T-nuts are behind the rails, difference in screw size and hole size. Okay, well, all of these T-nuts that slide in for this, they're a M5. And I don't even know what this counterbore is on these things, or what the hole size is either, because they are whatever they were sent me. I didn't measure. But I show in the videos, maybe you haven't watched it yet, Mitch, but I show in the videos, and that's another thing that's included as part of this package. Anything I can provide that will help make it easier. I have what's called an alignment jig, linear rail alignment jig is what I call it. And it's basically something that you can mount to the top of this rail, and then it's a little block that holds here, so it helps to align that rail, which should be from here to the center line is 20 millimeters. So that block is actually 10 millimeters here. So you would slide your linear rail in loosely, put those alignment jigs on. I had one here, and one there on the end. And then as you're tightening those up, you're holding it against that to try to get it lined up. Same thing with this. When I did the video for this, I put one on this side. Then when I was putting this other side on, I flipped it over and put the alignment jigs down here. But I found that most of the time, what you really need to do, because you don't know that all this is going to line up exactly right. So the thing to do is to try to use the alignment jigs to do the top one. You can come back and loosen these up, and then move the X over. And when you get it over here close, snug that one down, then move it back over here, snug that one down, and just keep going back and forth, because this rail will then get parallel with this one based on as it's moving across there. It's going to go where those bearings tell it to go. I hope I've answered your. Can it go to a 4x8? I haven't designed a 4x8. You want to jump on that, go right ahead. But a 4x8 needs something. You would either need some really, really big ball screws so you wouldn't get the whip, or you need something like rack and pinion. These are, I'm not here to get anybody no 4x8. I almost didn't do the 4x4, but I thought, well, if I'm going to do the 4x2, that's going to be a 15 millimeter gantry, so I might as well do a 4x4 because I know there'll probably be somebody that wants it. I know how people are. They always think they got to have the biggest, go big or go home. And then they end up using the first 2 feet or so.
Yep.
But yeah, I'm not in no 4x8 game. You got to have one of them.
Alt mill.
It's a whole different animal to try to design something for something that big, because these components aren't really the type of components you would want to work. 4x4 is as big as I would want to go with the type components. Now, linear rails are all right, but the ball screws just wouldn't cut it trying to do a 4x8. All right. Is there any? I guess I'm counting
Yes,
on y'all.
Steve, I am the number 2.
What's that?
Steve asked earlier if I was the number 2, if I was really the number 2.
Yeah, you ended up being the number 2, I think.
Yeah.
Let's see. Let me check my notes, see what else I was going to cover.
Jerry wanted to know, in today's prices, what might it cost to build each one?
Well, I don't know for sure what it would cost to build the bigger ones. I haven't really even added this up, but I did check some figures. I can tell you what I've got so far in some of this, and then you can kind of base it off that. But material prices, when you're talking aluminum and extrusion and stuff like that, they go up and down. So if I say, well, it's probably going to cost you this much to build a 4x2, and then you end up trying to build one that costs you way more, you're going to go, man, Dave's stupid. He said it wasn't going to cost that much. Well, I'm not going to try to tell you, but I will tell you what I've spent right now on this one. We'll start off with the 40 series 4080 extrusions. I got those from 8020, which is the original place. There are other places that make it. So if you try to go, say, oh, well, this place has got it cheaper, like McMaster. I doubt McMaster would, but you find some other place, you better make sure it's the exact same profile, because sometimes they are not exactly the same. The webbing's different and all that, but I would stick with the 8020 company and order it from them. But those were, and again, I'm ordering them 900 millimeters long. I'm not cutting them, not doing anything to them. They were, where did I put it? $71.47 a piece. So I got 2 of those. So that's $142.94 for this piece and this piece. Okay. This piece, this is the 40 series 8016 aluminum extrusion. It is also 900 millimeters long, and it was $228.41. And by the way, I don't have this totaled up, so if somebody wants to write these down and total it up as I'm saying them, then you can get an idea. I might put on my glasses to read my chicken scratchers. Okay, the linear rails, all of the linear rails, I've got 4 of them on this machine. They're all 900 millimeters. They come as a kit. I bought these from Amazon. The links are on my website. There's a link to my Amazon store, and I have put all the components that I got off of Amazon in that Amazon store. So you won't have to go hunt for anything. You can click on it, go right to it. And yes, I might earn a nickel or two if you buy one using my link. But if you don't want to use my link, don't. Go hunt for it yourself. So the linear bearings, they come as a kit of 2, like I said, and then you get 2 of the linear rails that's already on each bearing. You get I think they provide the screws too, although I didn't use them. I used some different screws for it. They were $32.51 per rail and 2 linear rails. As a kit, they were $65.02. So that's a set of 2 linear rails, 4 linear bearings, $65.02. Okay. The ball screws, again, all 3 of mine are the 900 millimeters. They are $52.99 each. And I bought 3 of them, so that's $158.97. Now, the ball screws come with everything you need. They come with the ball screw. You can't see it behind here. Well, I guess now you can't see it anywhere. But they all come with the ball screw nut and the nut housing, which is that little aluminum piece that's screwed to the side of the outside of the upright. They come with the this is the what they call the BK12 ball screw support. This is a 3D printed spacer block right there. But they come with the BK12, and then this one is what they call the BF12, which is the end stop is what they call that. So all of that comes with the ball screw. It even has the little grease fitting to screw into the nut housing, or actually into the ball screw nut, so you can grease it and all that. So all that $65, or I'm sorry, $52.99. I bought 3 of them, $158.97. Okay, the half-inch aluminum plate that I used to cut all these aluminum plates you see. Well, this is 3/8, as I mentioned, but the 2 uprights, all of the spacer blocks, the XC mounting plate, all that's half-inch. And I ordered one 4-foot long piece of 1/2 inch by 8-inch aluminum flat bar, 6061, which is important. You want to get 6061. Don't get anything else. Don't get none of the fancy, expensive stuff, or don't get something that's softer than that. You want to get the machinable 6061. I think it's T6511 or something like that. That 4-foot piece of aluminum by 8-inch flat bar was $169.64. But I got both uprights, this, and both spacers. All of that came out of that one 4-foot piece. The 3/8 piece for these 4, I don't have a way to tell you the price because I had some of this laying around that I cut these out of. But I did look up what it would take for a 2-foot piece of 3/8 by 6-inch 6061 aluminum flat bar. And at Metals Depot, that's where I buy all this stuff. A 2-foot piece of 3/8 would be about $65. And that would be way more than enough to get all 4 of of these pieces, the 2 front plates and the 2 rear plates. You could easily get all of those out of there. As I mentioned earlier, the Z-axis assembly was $170. So I don't know, like I said, I don't know if anybody's adding this up or not. Hardware, somewhere between $50 and $100 worth of hardware. All the hardware on here is metric. These are all M5s. There's some M6 right here. All of it in the plans. If you've already bought the plans and looked them over, you already know that I call out every single one, not just, whether it's a socket head cap screw or whether it's a button head screw and what size and pitch and all that. It's all called out, length, everything. So when you go to order that, here's one thing. again, in my Amazon store, I've got all the hardware that I bought because most of it I'd get off of Amazon. But there is a slight advantage to buying from someplace like McMaster Car, and that would be that with Amazon, you have, there's so many different things, and all of them's different sellers, and so you can't just go in there and order everything. It's not all going to come in the same day. It's going to, come in all different times. The thing about McMaster is it's probably pretty much the same hardware made in the same place, but you order from McMaster, you're going to get it probably in 2 or 3 days. And if you order 15 different kinds of screws and hardware, you're going to get it all in one box because they have everything, but they are higher priced and they will charge you for shipping. But the trade-off is that you can get it all at one place and boom, you'll get it all in the same whatever day their delivery date. I have a master distributor in the other side of Atlanta, on the west side of Atlanta. So I can order something from McMaster and I'd have it. I could order it right now and I'd have it tomorrow. UPS would bring it tomorrow. They are quick. They're really quick, but they ship everything UPS and it is more expensive. Now, don't go on McMaster and order just 25 of these button head screws because it'll cost you a fortune for shipping. You have to get a big order of something if you're going to order from McMaster like that. Okay, got a question. Hey, Dave. That says you got which wire?
Yeah, I don't know what's the TLS.
That. Which color wires you use? I'm not sure what he's asking there. As far as wiring this thing up, I've got shielded wire going to the stepper motors, four wire shielded going to the stepper motors. There'll be a little beefier gauge going to this because I've got they send this and it just comes with this thing right here. So you gotta wire that, gotta solder that up and all that. So, and I'm waiting on that wire to come in, but that'll be some little hair. I think it's 16 gauge is what I'm going to use, and only some people use 18, but I'm going to use 16 because all my research says that if you might want to go 16 if you're going to use a longer run, and I might end up using a longer run because my VFD is going to be way over there on the wall. I hadn't decided yet where this thing is going to live when I get it all done. So I'm not sure if I answered your question about color wires and all that, but
it's not going to hurt to run 16 gauge anyway.
No, well, I asked AI, the all-knowing AI, and they came up and said 18 gauge is okay, and we probably handle it. But if you're going to do a longer run, use 16. So I thought, well, then 16 can't hurt anything, even if I don't do a longer run. But and that's what I'm waiting on. I hadn't got that in yet from Amazon. Another thing I might mention too is we've all seen these little live videos. In some cases they do it live, and other times it's just a regular video where they're doing their little speed test where they got the thing zipping across there and showing how fast it'll go and how it's cutting, but they don't ever show it actually cutting apart and moving around. It's always just one straight line across. So these are all 1605 ball screws. 1605 means that they're 16 millimeter, 5 millimeter pitch. All right. those guys that are building some of those other machines that are a lot more expensive than this and want to brag about how fast they can go, they're using either a 1610 or maybe in some cases a 1620. So it's got a much longer pitch. In other words, if this ball screw turns 1 revolution, mine is moving 5 millimeters or 0.196 of an inch. If it's a 10 millimeter pitch, then it's going to move 0.39 of an inch or 10 millimeters every time it turns. If it's a 20 millimeter pitch, it's going to move 20 millimeters or 0.787. So that's how they're getting the speed. But like I said, I think those speed tests are a joke because you never see one. You always see it go and across, but you don't see them do a square or an angle or anything. You always just see that straight line, and then they brag about how fast it is. Well, if speed is more important to you than accuracy, by all means, feel free to shop and get a bigger pitch ball screw. I have found I've got 1605s on this. I got 1605s on my big machine over here. I have found that it is plenty fast for me, especially with when I'm cutting, that I don't need it to go any faster than that. Again, these are hobby machines. Uh, you know, they're I'm trying to make a machine that's accurate. Speed is secondary to me. So, but 1605 is what I spec out. Anybody wants to, and keep that in mind, because if you get on Amazon and you find one of these and it's a 1605 and you're going to use them for the Y-axis, and then you go online, that's the only one they had, you got this one, 1605, and then you go find another seller that's got one, you buy it and it's a different pitch, it's going to be problems. Try to keep the same pitch on whatever you're using. So, I mean, I guess technically you could tune that motor and get it to work, but that'd be more trouble than I'd want to do. So, let's see here. How are we doing on time? Are we already over, ain't we? I'll tell you what, let's do. Let's take a break because I'm about talked out for that. Oh, he's talking about that tool setter. This is the exact same that you can see. This just come in the other day. I've barely taken it out of the box. This is the exact same tool setter that I have on the other machine, and I have a video on how to set it up with that one. I'll probably do another one with this machine, but as you can see, I've still got a ways to go before I'm ready to get this. And one thing I'll do different, no doubt, is on that machine I have the tool setter kind of up here, and it's sunk down below the table. It's flush with the table. On this machine, since it's smaller, I'll probably leave this one setting like this up somewhere and then have it to the back somewhere. I'm not sure where I'm going to put it, but yeah, you got 4 wires to these things. 2 of them are for the tool setter part when it first goes down, and then the other 2 trigger an e-stop if it for some reason doesn't stop and it goes all the way down. It keeps from messing something up and breaking the tool. I don't remember off the top of my head which ones are which, but again, I have a video on my YouTube channel where I did it on that one. Exact same thing. All right, let's I'm gonna get a drink of water here while I'm quenching my thirst. If I can find it, where did I put it? We'll do a giveaway.
Ooh.
Hashtag bear.
There you go.
So put that in. Let's see, it's almost 120. We'll give them We'll go to a 121. We'll do a minute or so. Everybody get their hashtag bear in there, and we'll give away a gift certificate for Cadence Manufacturing and Design if this is your first time here. And I'm sure some of you folks are your first time here because we got a big crowd tonight versus what we normally have. So, yeah, we do a giveaway for a $25 gift card from Cadence Manufacturing. And then once you get it, you can go to Cadence Manufacturing and Design and get you some awesomeness. And if you've bought my plans and need a bit that will cut aluminum, I can definitely recommend his O-Foods because that's what I use to cut all of these. And the finish is just plenty good for what I want anyway.
Mm-hmm.
And if anybody's wondering about these, let me see if I can change the camera angle a bit. I don't know what I'm seeing over there. Let me flip this up here real quick. So, you can't really see it too good, but it says Gatton CNC 2.0 right there on the side of the uprights. And then I also have it right here on the front plates. These are an old revision. I revised them, but some of you may remember. Some of you may remember when I was doing the test with the laser.
Yeah.
So I cut the aluminum parts. This one has 4 tapped holes. So if it's got any tapped holes, you want to tap the holes before you do anything. Then I take my orbital sander, put 60 grit sandpaper in it, and hit it to put a nice kind of circular brushed, I don't know what you'd kind of call it, but a kind of a brush finish to it. And then I get some flat black paint and paint them. And then I put them on my Creality Falcon 2 Pro 22 watt diode laser and engrave that Gatton CNC 2.0 on there, which is doing nothing more than removing the paint. And then after I get that done, then I come out here and spray them, hang them up, spray them with a little clear lacquer. And they come out great. Kind of fancy for something like doing something in their garage, I think. But yeah, you don't have to get that fancy if you don't want to. But if you want to, the font is Acme font for that, and it's even in the drawings. It has it. I think it has it in the files for that. You don't have to put it on there if you don't want to, but it's there. All right, it is time to pick a winner here. I don't know how many we got. There's that button that I couldn't find last time. I don't know what the deal is. All right, so there we go for a gift certificate. Good luck, everybody. And here we go.
Here we go. Who's gonna win it? Who's gonna win it? Dun 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 dun. Oh yeah, Stanford.
Stanford, yeah. All righty. Okay. Since I don't think I probably already got your email address, go to my website, click on the contact link, and send me an email with your email address. I need your email address and your real name, I guess, but I don't need your address or any other information, just because these gift cards are all sent through with the email thing. So send that to me, and I will get that Probably get that done tonight as soon as
Congratulations.
Yeah.
get out of here. All right.
Very nice.
I still got that on there. All right. Any other questions or comments or
I don't think
what
so.
have you? I
I
think
think it's
I've.
pretty awesome.
Let me talk about one other thing. You know, I keep coming back to these STL files for these 3D prints. Not only do you have one to make your own. Let's see. Let me throw this back on here. Let me make everybody dizzy. Okay, there we go. So not only do you have them to print out your drill templates or your center punch templates, I guess, but anything else that I come up with, I'll throw the STL file in there, or I'll post it on the web page or whatever. You're welcome to use it, or you don't. I don't care. But one thing I thought of is, let's see if you can see. Yeah, I guess you can see these. Well, I guess these work better. You know, when you've got this extruded aluminum, and of course I'm wanting to cut aluminum, and I know how aluminum goes everywhere. But I kept thinking, man, it's going to really fill up this groove right here on the top. So I 3D printed, I call these groove fillers because I couldn't think of a better name. But what I did is I took 900 millimeters, and then I know about what I can cut lengthwise on my build plate on my bamboo.
Yeah.
And so I made 5 of these. These are just over 7 inches, I think, and they fit. If I can get it in there. They fit in there, so that will cover, you know, help keep chips and dust and what have you in there. And then after I come out here and did a little more, I thought, well, let's do even one better than that, because you still got this linear rail right here, and of course the way they're shaped, you got kind of a gully right there. And I know from my other machine, that's where all the chips go right there. So then I came up with this little thing, same concept. I took 900 millimeters and divided it by 5 and got 7 and some change. And these, let's see if I can, you can see that little step right there.
Yeah.
And then there's 2 holes. So you print out a bunch of these, and I don't know if you can see it or not. Right here I have some of those roll-in T-nuts. But you can take these, and again, you'd put all of them on here so this whole thing would be full. But that little step rides on this part, and then when you tighten up the T-nuts, I know y'all can't see this, but when it's tight and pressed against there, now there's a gap under here. So if you look as I push this, you can see that clears over those linear bearings. So
Nice.
if all of these are full, you can ride it. I call this my chip guard. So the STL file for that is included in there. Like I said, if anybody wants it, fine. If not, fine. Anything else I've done, I've got the STL file for all these different spacer blocks. I didn't do one for these kind of things because these are just like tubes. Anybody can make those. But anything that's got some shape to it, I include the STL files. If you want to get fancy, this one's out of green. But if you want to get fancy and put GAT CNC on it, you can. And
You
like I
could have made
said,
that reverse print and made a stamp out of it.
well, like I said, anything that I make, I'm like, okay, well, I'll just throw it up there. If anybody wants it, it's there. If they don't want to use it, they don't have to. But I think that's
very good, sir.
Oh, one other thing about the prints. Uh, Anybody that knows me knows that I very, very seldom print anything with like 15% infill. I Something
Yeah.
like this. These are 15% infill because they're not doing anything. They're just there. You know, they don't have any weight on them or anything like that. So those are 15% infill, I think. Anything like this spacer block where you're going to be tightening and squeezing that thing, these are at least 50% infill. More than likely, they're 100. Sometimes I do 100. So, and the cool thing about doing, and they're not, oh, by the way, too, they're not PLA, they're PETG, which has a higher temperature thing than the PLA. PLA might work okay on this, but I like to use PETG. My bamboo seems to love PETG. So PETG, 100% infill on some of the stuff where it's going to be taking a load of some kind. And let's see, there was something else I was going to say. Oh, if you print 100%, like I've got, I don't know if you can see it. Let me make y'all dizzy again for a second. Let me come around here. See, I made this this is a 3D printed bracket right here, and it's screwed into a little roll-in T-nut in the screw. So then it comes up at an angle, and then it's got the switch here, which catches the back edge of the upright when it's homing. Well, if you make these at 100%, you see I've got these two little M3 socket head cap screws. It's real hard to try to put a nut on the underside of this. So run these at 100%, make the hole size just like you would if you were drilling to tap them, and you can tap that plastic. It works great. And you know, it's enough. I mean, because you see what it's holding. It's just holding that little switch. No big weight or anything. And all I need is for the screw to have something to grab. So if you run 100%, I do that all the time on plastic stuff. Instead of trying to put the hole and create the threads and let the 3D printer do the threads, and then you find out it don't work and you cuss a little bit, it's just easier. And maybe that's just the old sheet metal guy in me to put, just look and say, okay, for a M3, I don't even know the hole size for an M3, but I'm going to say it's 2.2 millimeters or something. You just put that in and make the 3D print hole that size, and then you can, man, somebody got quiet. Did somebody turn something off or what?
Ryan muted himself.
Okay,
Yeah,
I was going to say, man, it got super quiet there all of a sudden.
I've been muting myself the whole time.
Oh, okay.
Yeah.
All right. But yeah, 100% infill and make the hole size what you would normally do, like if you were doing metal. Make the undersized hole and then tap it, and the threads work good for putting little screws in plastic like that. All right, we've been on here a good while. We've had a pretty good old crowd tonight. I'm trying to see if I've did anybody add that up? I added it up in the house, and it was still well under $1,000 for what I've got here. Now, again, remember, you're still going to need drivers,
Maybe.
some kind of controller, and all that stuff. I'm not even counting that. All I'm talking about is the stuff that you would buy that are in the plans to do this. Because no matter what you build, you're going to need a controller and stepper motors and either a computer or a Masso, something like that. I just happen to have that old Generation 2 Masso. It's 9 or 10 years old, and the thing still just works freaking awesome. So I just couldn't stand to have it just sitting around.
Yeah.
You know, because I thought, well, when I do this, I might as well just throw together a little console and use this thing. So
Looks good.
Another 3D print I have is right here, and I don't know if you can see that on top of there because obviously that switch isn't going to read plastic, but I have a shiny copper penny CA glued to the top of that 3D printed flag bracket right there, and it works fantastic.
A rare penny?
A what?
A rare penny?
No, not a rare penny. Well, it could be rare.
They
I
all are
didn't look.
now.
It's just a shiny.
They're extinct now.
Okay, well that's why I felt comfortable gluing it on there. At least
At
my
least you know
machine's
where
not
you'll have
worthless
one.
now. It's worth at least a penny.
Yeah.
But now I happen to have one, and I thought, well, let me see if it works, and it tripped that switch good. And I thought, because I thought, well, if I put a washer in, a washer's got a hole in the middle, but a penny's more solid. So I just glued it to that 3D printed little flag, and it's working great.
Good
It's
idea.
home and fine. You can see this one now. I don't know if you can't see from all that's in the way, but that switch right there hits enough of the back face of that upright to home there. Oh, I didn't show you the, let me drag you around here. Well, I may not be able to go that way. Are y'all drunk yet? Let's see. Okay, there it's showing. What's up, Big Bear? All right, now this is, you can see this is one of the other kind of proximity switches. This is the exact same bracket that I have on my big machine, and it works so well that I thought, well, don't reinvent the wheel, Dave. Just print out another one. So printed this one out. You can see this is just a little piece of aluminum angle. I think it's 1/8 aluminum angle, and I just cut, I don't know how long it is, 1.5 inches or something. Put in a couple little things, and see this, you can slide this to adjust where you want your home position to stop. I don't have mine super close up there, so, but you can see it's tripped that switch and then backed off of it. So that works good for there. This bracket here, again, let's see if you can, let me try to.
Yo ho, Pirates Life for me.
Let's get it right there. This bracket right here, this is another, probably at least 50%, if not 100% infill print. But it serves a couple of purposes. I'm using, well, you can see there's no nuts on these screws, or I think you can. So I put a little boss right there, and I tap those holes so that holds this on. And it's using two of the holes that are already in this Z-axis assembly. You can see I use a real fancy connector here. I love terminal blocks. Aircraft connectors are great, but if this comes apart, you can find it real easy by using these terminal blocks. I have ferrules on this side and fork connectors on this side. But all of this bracket, and then it doubles where it hooks the drag chain. I thought he was about to pull the camera over. But all this stuff works good. Like I said, I'll be including all of these kind of STL files, anything I make. If you don't like it and want to do your own, you ain't gonna hurt my feelings. But I figure if I got it and y'all want to use it, I'll put it out there. Another thing I did, now this is kind of cheesy, but I'm gonna show you. Oh, he unplugged the camera, didn't he? Because we're not even on no more.
No, he didn't unplug it.
Yeah, he did.
Oh, he did?
Yeah, because the camera's not on.
Oh,
He didn't step over it like I do. Now let's see if I can get it to come back on. I probably have to jump through hoops again. Yeah, there's an extension thing to get it to go around there that far, and he tripped on it. Or okay, let's see if it comes back. No, it ain't coming back yet. See if I add it. There it is. It's dark now. Let me see if I can get it to come back. Let me remove that camera now. Oops. Now I'll add another one. Add it again. There it is. There we go. Okay. All right. Okay. Now these little, what I was going to show you, this is probably a little cheesy, but you know, if it works, it's not cheesy to me. But I made these little things. Let's see if you can see it. You see how the shape is? And I even put a hole in the top thinking I would need to put a screw in there to hold them, but they fit so snug. But they work great because all these wires that are coming behind here, you can just feed them in here. Let's see if you're seeing it.
Yep.
Yeah, and then you just push it on. I got 3 or 4 of them. I guess 3 of them back here, so it kind of holds the wire up, somewhat organized. You know,
Nice.
it's that's pretty good for old Dave. You know, that's about as good as it gets as far as organization, right there. Yeah. But all right, well, I guess that's it. If anybody else has any more questions or whatever, like I said, I'm wanting these plans to be some of the simplest, easiest to build machines out there. There's a lot of other folks that make plans and stuff like that, and man, they are way complicated. A lot more parts and a lot more work and stuff like this. And I thought, well, you know, like I said, I like the KISS theory of engineering: keep it simple, stupid, and just use something that's readily available. You just buy the components, a little bit of work with the aluminum plates and tapping and stuff like that, but all the rest of it is really not that difficult. So, all right, let me get that out of here. All right, I have not seen any of the comments, so any other questions? Or yeah, I'm way behind on comments.
Well, you got a few people that are interested in building one.
Jerry said, I would make the table deeper than stepper motors to avoid running into the back wall. That's a good point, Jerry. This was a rolling workbench that I already had, and actually it was 30. It's 58 inches by 30 inches, and you can see this is a piece of plywood that I happen to have in the back of my truck, and I made it. I think I made it 36 inches deep, something like that. I think it's 36. No, 38. So it hangs over 4 inches on both the front and the back. But you're right, the stepper motors do hang off the back, so you got to be careful about shoving it into the wall. And just as I'm working on it, I poked myself because those stepper motors are the old kind that have the dual shafts in the front and the back. And I've already poked myself, I don't know how many times, but yeah, if I was building a table from scratch, I would have definitely made it bigger. And that's another thing I put on the website. Somebody had asked about the actual footprint. So I added that to the website. If they scroll down somewhere on that first page, it'll say what the footprint is minus the stepper motors, because everybody knows, you know, not all of these are the same length. You can get longer ones. I have some that are longer than this, but and of course you could use NEMA 34s too if you wanted to. If you want to do those adapter, I probably will be making some of those adapter plates uh, once this thing gets up and running. But yeah, all the footprint sizes for all four different sizes is on the website if anybody needs that info. And anything that when they go on the website, if there's anything they don't find and some information they want, just click the contact link, send me an email, and let me know. Or if you need help with the build, uh, you get stuck on something, or maybe you're watching the videos and something didn't just click and you don't get it, shoot me an email, and if I can't answer your question clearly enough in an email, I have this live stream software or app or whatever it's called. We could do a quick face to face, and you know, I could talk you through something there. So I just don't want anybody to get stuck building this thing because it's pretty easy. It really is. It's not that hard at all to put these things together, especially when you got somebody like me that's already figured out all the stuff for you. All you got to do is follow the videos, and uh, I would say the drawings. I think the videos are better than the actual drawings um, on a lot of that stuff. But there's a lot of people that are wanting to build a CNC may not have ever seen a blueprint before. So, but they have watched videos. So, all right. I guess we're coming up on 2 hours. I guess we're pretty done. Thank you, Alan. Appreciate you, buddy. I keep waiting to see if Alan's going to build one of these because he's built everything I've ever designed before. He's all the other ones he's done. So, all right. And if anybody has any other questions that you don't think of until after we're off the air here, just leave a comment. Once this becomes a video, just go leave a regular comment down there because I'll read all of those too. But anywho, I guess we'll get out of here then. Paul, you got any parting words?
No parting words other than, hey, get out your wallet and buy a Gatton CNC version 2.0.
Well, I don't think anybody's going to find a better value because, like I said, when you get these plans, you're not just getting one machine; you're getting four different sizes. So most people don't do that when they sell plans for a machine. It's just it is whatever it is they built. But yeah, you get four, and like I said, pick the size that's right for you and build it, or build one of each. I don't care. Um, and one last thing too is you'll notice this is just sitting on a plywood thing. All these I have created like bench top machines because I figure if I have to design a table and provide plans for you to build a table, then maybe you don't need to be trying to build a CNC machine. Anybody can throw together a workbench. Doesn't have to be fancy. Or if you don't have time to do that, go buy one of those Craig bench things that you just bolt together or whatever. They sell those. So, yeah. So I didn't feel like it was, I could have added a bunch of cost to it by adding some more aluminum extrusion for a table frame and all that. But then if you want to go that route and you got deep pockets, go right ahead. But I'm more about simple. Just build something that you can set on a workbench like that and go.
Paul is hating you right now
Why is that?
because it's so far past his bedtime.
Oh, okay. Well, we gotta go, folks, because Paul's
It's
got to hit
probably
the hay.
past Dave's bedtime too.
It really is. It really is. And I know
That's
it's
all.
past Bears. He's disappeared again. He's probably already snuck back in there to the bed. Got on.
That's why he was trying to unplug the camera.
Yeah. But all right. What about you, Ryan? You got any famous last words? You want to plug your thing? You might as
Saturday
well.
night we got Making It Up As We Go, talking about videos and stuff like that. And, come on over, hang out. It's all good. Fun times. Thanks.
All righty. Okay. Well, I guess that's going to do it. Thanks, everybody, for tuning in tonight. Like I said, we've had a good crowd tonight. And thanks for being real responsive with the plans and the Facebook group and all that. We hope to build another little cool community around the Gatton CNC 2.0. So
It's a good looking machine.
Can't wait to see who gets the first one built. That'll be fun.
It will not be me because I cannot finish a project.
Well, you finished those things behind you there.
No, they're not done yet.
Oh,
Yeah. There's still more crap printing. I have to I'm reprinting some stuff right now for one of them because the print, it keeps warping, but I think it's because I was printing the parts out on this one down here, and it being closer to the floor, and I'm in the basement. I think they're just warping more. So
Yeah. All righty. All right. Well, thanks, everybody. Like I said, if you got any more questions,
thumbs up.
shoot me an email or leave a comment down here to this video, and I'll certainly get back with you as soon as I can. And if you got any other, if you see something that I left out that you'd like to see included, or something that you think would be better, I'm open to suggestions. Any updates I'll do. What I'm going to do is I've got a page that I just added today on the website, and it's just called notes. So every time I update something, I'm putting the note saying, okay, on 3/25/26, I updated this, and I'm kind of going to keep a thing. So anybody can go up there and see that. But what I'm going to do is if I change anything, instead of trying to go to all the people that have already bought and say, hey, here's the new file that I changed and added this, and now it's better. I'm just going to put it on the website and say, okay, here's an update. If you want the new thing, there it is. If not, you'll have the old one in what you've already got. So it's a whole lot easier to keep up the website changes than to try to keep up with everybody that's already got them out there. So anyway, all right, I guess we're going to get out of here. Everybody have a good rest of the week. And congratulations again to whoever's Stanford is. I don't know who that is, but congratulations. I will check my email and get your gift certificate for the Cody Bits to you probably tonight. So have a good one, everybody. We'll see y'all.
See ya.
yeah.